Morning. So my name is Nikolai. I work for Automatic. You can find my website at extrapolate.me, and I'm Nikolai beyond Twitter. Recently, there is a lot of chatter about the WordPress REST API. Even Ryan spoke about it yesterday. And most of the time, we use the REST API to power single-page in-browser applications. Before I talk more about how we build those, let me just spend a minute about why would we want to build a single-page applications. So there are two main reasons. One of them is that they can be much faster, because we don't need to refresh every time the user does something. And the second reason is that they can be a lot more engaging, because we can keep a lot more state compared to a classic HTTP only based application. Before I continue, I would like to take a step back. And first, I want to acknowledge that Chris Lemma is a really tough act to follow, but I can agree with him about one thing, and this is that it is really important to think about change and how it affects us, and what is the impact of change in our lives and in our code. I don't know if Chris has impact analysis ready about this change, but we know one thing about change and people, and this is that change is hard, and very often people hate change. You can see this in every generation who says the next generation are illiterate degenerates, and you can see it in the millions of people who never ever like the Facebook changes. Another thing related is that it is incredibly hard for people to follow change in state. If you don't believe me, watch this. Can you follow it? Following changes is hard. People so much prefer a comfortable place where nothing changes much, everything is static, everything is cozy. And actually, this is exactly what is the difference between a classic web application and a single-page app. Dealing with change. In a classic app, whenever something changes, let's say we want to create a new post or update a new post. What happens is that we press a button and the whole page refreshes, right? So every single time in a classic app we do a change, we basically throw away everything and re-render everything from scratch. In a single-page app, unfortunately, we do not have the luxury of starting from scratch. We need to somehow account for the change. And even if it's something incredibly simple, I'm sure all of you have written a button which shows and hides something. And even for something as simple as this, dealing with change can be hard, because there are a lot of different possible states to remember and to act on. And the main thing I'm going to talk about today is React, whose main purpose is actually dealing with change. React was built by some cool guys at Facebook, and it is an open source UI library. It is not a framework. It is just a simple open source UI library. In the core of React is building components. Each component mostly consists of a simple class with a render function which returns a bunch of HTML. As you might notice, As you might notice, this doesn't really look like JavaScript code, right? And in fact, there is a compile step which makes this code into just plain JavaScript objects. Is there a chance we can change the screen a bit? Or actually, let's see if this is working. No, it's the same. Okay, just a second. I don't think this works. Actually, I think it would be much better if we just continue. Okay, this compiles to just plain JavaScript object, and the language is called JSX. It's actually pretty cool because designers can work with it really easy. The next thing is that it is incredibly easy for us to nest components. As you can see here, in addition to the p tag, we have a post meta something, which is not really an HTML tag. But the coolest thing is that post meta is nothing more than just a reference to a JavaScript variable. And in our case, it is just another React component. And see, when we nest components, all the properties we pass here, all the attributes, are actually accessible inside the child component as this.props. Whoa. Oops. Also, each component can have its own internal UI state. For example, in our case, a post meta component can probably have some state saying whether the extra meta stuff is hidden or not. And we can access it via this dot state. And anytime we want to change something, we can call set a state which lets React know that the state changed. The coolest thing, however, is that anytime either the props change from a parent or the state changes, React automatically re-renders the component for us. It automatically changes the DOM elements and the HTML, and we don't have to do it by hand. So these are components, and let me tell you a few more things about why they are so cool. As we mentioned before, components are composable, which means that we can have, this is a master bar, we can have a user greeting component, and we can have an avatar one. So they very quickly become the building blocks of our application. Instead of having divs with just classes, we can just have we can have the main building blocks of our application look like tags. For example, here we can have a master bar, a navigation, which you can't really see. And each one of them can in turn include the HTML itself, based on the props. Something incredibly cool is that there is a Chrome extension with which you can just go to a website that uses React, and it allows you to browse all of the components there. You can just go either to some of the new pages of WordPress.com, or for example to Messenger.com, which is the new Facebook thing built entirely with React, and just see what kind of components they have. And it can be a lot of fun. Components are also easily testable because they're small confined things. And it makes it so much easier either to mock stuff or to test in isolation. Components are really good at preventing XSS because by default, they just escape stuff. And in the rare cases when you actually wanna use HTML, let's say you are rendering something coming from the, let's say, a WordPress post, there is a special prop called dangerously set inner HTML, which every single time reminds you that it's actually pretty dangerous to use it. And this works wonders. People just avoid it whenever possible. Also, React components are not templates. They're not using some very simple but underpowered templating languages. We can just use the whole power of JavaScript instead of reinventing the wheel with weird syntax which doesn't really allow us to do everything we want to do. Components are reusable. Let's say we want to have an avatar everywhere in our app. One thing we can do is that we can have just an avatar component, and the only thing it needs to know is an email, because gravatar URLs are based on emails. And everywhere in our app, we can just use avatar, email, and this will be enough. And it will take care of all of the image URLs. It will take care of any wrapper diffs. And in general, it makes it really easy to avoid boilerplate. Even more, if we decide that this avatar needs to show a profile page on hover, we can actually add the JavaScript needed inside the same component. So that this way we need to change only one thing. We need to only change the avatar component, and every single place we use it gets all of this functionality for free. But wait, there is this incredibly common best practice that tell us that we should keep logic and markup separate, right? We have learned this from the start of us being web developers. Logic lives here, markup lives very often in a separate file, right? And of course, separation of concern is good. It's even great. But I have a few questions for you. How often have you needed an event handler without the very specific DOM elements it is bound to? How often do you need the on-click without the button? Also, how often do you need just a DOM element, a plain DOM element without the JavaScript that makes it alive, especially in a more complex JavaScript application? So, HTML and display logic, of course I'm not speaking about business logic. So HTML and business logic are actually the same concern. They're not different concerns. So separating them in the front end, especially, is not separating concerns. It is separating technologies. Because JavaScript is a different technology from HTML, doesn't immediately mean that they're different concerns. And thus, keeping us separate is artificial. And I'm sure all of you have had the situation that with every change in an HTML template, you had to change a corresponding JavaScript file. So, again, display logic, like event handlers and stuff, and the HTML, the markup, are the same concern, and they belong together. We talked a lot about components until now, why they're cool and how they work. But we didn't say much about the elephant in the room. And this is, how about this re-rendering thing? So every time we change the state or we change the props, everything re-renders. Isn't this slow? Well, in practice, it turns out it is really fast. Every re-render turns out to be fast, and the reason is that React uses something called a virtual DOM. Instead of using the browser DOM, it builds its own representation of the DOM. And on every update, React runs our render method. And this is why render shouldn't have any side effects, because it's run a lot, and should be fast. So based on the result of render, React builds this tree of DOM elements in its virtual DOM. After that, React diffs it with the previous tree, with the current state of the DOM. Then it has some semi-complex algorithms to compute the minimum set of DOM changes to move us from the previous state to the state we want. After it does that, it does a really smart batch execution of all of the updates. If you have read about performance optimization in the browser, the first one is do not make a lot of DOM updates, because a DOM can be slow if you don't know what you're doing with it. And React solves this for us. It makes sure it makes the smaller number of changes not as often as it's too much. So the virtual DOM is fast, but it has some unexpected advantages. For example, if we use a virtual DOM, we can do server-side rendering, and this is extremely cool. Because you can have an isomorphic application, you can have all of the SEO you want while still having a fast, responsive, and an engaging application. Also, you may choose not to render this virtual DOM onto the browser DOM. You can say, oh, let me add a mustache attribute to my avatar element, and then something in there will just render it to a canvas. Or we can run all the rendering in a web worker and make it really parallel and fast. You saw the virtual DOM is cool, but I have one last, and probably the coolest, at least for me, property of React components. And it's that they're declarative. They're not procedural. Let me explain what I mean. Imagine that you want to make red velvet cupcakes. And then imagine that instead of following a recipe, you just do two things. First, you just pile up all the ingredients on a table. Then you show a picture of, this is my end result. This is the end result I want. And something in the middle, based on the ingredients, does some magic and gives you the cupcakes without you telling anybody what exactly to do. You just tell them you just give them the ingredients, and you tell them this is the end result I want. Deal with it. Oops. Just a second. Okay. And actually, this is what React does. You give it some HTML. You give it all the states in the HTML. This is your final HTML. Then you give it some props and state and say, okay, my props and my state are my ingredients. This is the HTML I want based on them. Deal with it. And React does. It's really like magic. And it changes a lot the way we think about our apps. Because every time you look at a component, you see the absolute final version of this HTML. See, you can see what will happen if the extra meta is hidden. It will be no. And you see what will happen if the extra state is not hidden. You see a paragraph. Well, in a normal jQuery-based application where you manipulate the DOM by yourself, you usually start with a very small set of HTML, and then something else, something which lives far away, adds to it or removes from it. And reasoning about what exactly changed my HTML or why is the HTML in this weird state, these are questions which are incredibly hard to answer in a normal application, while with something using React, it's pretty easy. And this is a huge change. We have been using it a lot for WordPress.com, and it had allowed us to add a lot of contributors to the project without the project very quickly becoming a huge mess. Of course, it's not all cherry blossoms. It's not all infinite spring. Again, React only gives us those small UI components. They're extremely cool, but we need to find a way to tie them together. We need to find a way for them to work together. And I really hope that there is a way which will not add so much weight to the process. And again, coming from Facebook, there is a thing called Flux. Flux is a pattern which lets you structure a bit larger application. It is based on a single direction data flow, which again helps us with dealing with change, but in the larger context of our app. Flux is not a framework, it's just a pattern. There isn't like a reference implementation. It is something like an architecture blueprint, and you can do whatever you want with it. I won't talk anymore about Flux, but if you're building a bigger JavaScript application, just find me after that and let's chat. So finally, I would like to do a very short summary of the things we saw today. First, let's build components and not just templates. Having the display logic and the HTML is pretty great. Also, let's not touch the DOM by ourselves, because very often it's fast and unintuitive. Let's just let React re-render stuff. Oh. The virtual DOM is pretty great, and it is both fast and it allows us to do a lot of fun things with it. This was everything from me. If you have any questions, you can either find me. After that, I'll be around all day, or Twitter is always a friend. Thank you.